All right, we're almost done. I know you were all anxious to get to the breakout session. So our last Spring speaker is the newest member of the Spring team. Came to us from Netflix Platform Engineering, and his name is Jon Schneider. Please put your hands together for the project lead of Spring Metrics.
Look at that, look at that. Today is all about new. I've never ridden a scooter before in my life, so I had to steal Peter's. I've never been on a main stage like this before. It's all new. I'm here to introduce to you a new technology in Spring Boot 2 that's going to help you better monitor and observe your applications. So I'm excited to do that. Before we do that, let's talk about something else that's new. Speaking of new, my wife and I, Christine, welcomed a new baby boy into the world 2 months ago. He's our third child, baby Zeke. We love Zeke. She delivered him at Boone Hospital Center. It's a hospital in central Missouri, in Columbia, Missouri. I know there's some Columbia people out here somewhere. All right, yeah. You know, for a small town, Boone Hospital is actually a pretty amazing hospital. It's super modern, really great nursing staff. You go into the rooms, they've got that luxury vinyl wood flooring and everything, really good equipment. Great place to have a child if you do that. One thing, that leaves something to be desired for is the food. The food was pretty terrible. That's common at hospitals. So we had Zeke, and we brought him home a couple days later, and thought nothing more of it. And a few weeks later, the hospital calls, and specifically the hospital cafeteria calls, and they say they want to speak to Christine, and they say, Christine, we have a survey for you, and she's ready, she's fully prepared to be honest about the quality of the food, right? And so they say, we just have one question for you. Was the food that we delivered timely? And she said, just kind of stops, and says, yeah, it was timely. I said, well, thank you very much. And the survey ended, and they hung up. I kid you not. And I fear that we do the same thing with application metrics. When I talk to a lot of organizations, I think pretty much every organization out there monitors system performance on some level. They monitor CPU utilization and memory utilization and disk consumption and things like that. And that's all fine and good. But like that hospital cafeteria, I fear it misses the relevant questions about what your users are experiencing in your application. Questions like this. Ask yourself right now, pick an application in your organization and ask yourself, what's the maximum amount of time a user waited for a response for my application in the last hour? Who could answer that question right now, like on their phone? Or like for something like Spring Security, how many times has my authorization framework blocked access to a resource in the last 10 minutes? Now you might find, in general, maybe Spring Security is blocking access to resources like 10 times a minute or something like that. Would you think differently if in the last 10 minutes, Spring Security blocked access to a resource 10,000 times? Perhaps there's, an intrusion attempt happening, something like that. Or a third thing, we use caches a lot. We use caches to speed access to resources. But, we make a trade-off with caches, right? We set an eviction threshold to trade off memory consumption versus speeding access to a resource. And previously in Spring Boot, we reported the cache hit and miss ratio across all time from the beginning of the app. But certain kinds of workloads can cause, cache thrash, right? That cause tons of evictions to happen, and that may degrade your system performance. These are the kind of questions I think are important to ask. It's like that old commercial, the thing that you would see before a newscast, like way back when. It's 10 p.m. Do you know where your children are? The question I want you to ask you is 10 p.m. Do you know how your services are doing? Or it's 10 a.m. Do you know how your services are doing? That's important. So to that end, we've created a new project. It's called Project Micrometer. It's a separate open source project. You can look at it at micrometer.io. And I like to describe it like this. It's like SLF4j is for logging. Micrometer is for metrics. Going along with the theme of Spring Boot offering you choice, Micrometer is an instrumentation facade that gives you a single interface to collect metrics against and export those metrics to a variety of different monitoring systems. Like ones we have right now are Prometheus and Atlas and New Relic and Datadog and Influx, et cetera. The list goes on, and there's more added every day. Pretty much as I learn about their existence, that's how it goes, or we get a contribution from the community. And the goal is just to maximize your choice. You instrument once, and you can ship metrics to a variety of different monitoring systems and explore their relative strengths and weaknesses. What I fear when you have to make a choice early, and if you were locked into a particular instrumentation client, is you may not know some characteristic of the monitoring system that's later going to come back to haunt you. You want to be able to switch fast, just like any technology. As an example about this, remember this guy, baby Zeke. We were back in the hospital, and they do this thing when, as labor proceeds, they put a heart rate monitor around the mother's belly to monitor the heart rate of the baby. This is getting very medical. The blue line there represents the baby's heart rate, and the red lines, of course, are a threshold that they've set, a fixed alerting threshold, such that if the heart rate exceeds this threshold, then the nursing staff comes crashing in like it's an emergency. Now, they were using, it's Boone Hospital, right? Like the premier medical center of central Missouri, and they're using a new technology. They're using a wireless heart rate monitor. It's Bluetooth. We all know how great Bluetooth can be from time to time. And this heart rate monitor just produced a ton of artifacts. You could see in this graph alone how many times that heart rate monitor failed to report a good heart rate, and it would drop below that threshold a bunch of times. And so basically, like every 2 minutes, the nurses were crashing in, because of but if you're a human, you look at this, and it's apparent to you that the baby's fine, right? I mean, your eyes just kind of gloss over those artifacts, and everything's fine. Unfortunately, the hospital's alerting system didn't support a concept called rolling count. So what you could do is you could take a minute window of time, and you could say, over a minute, if I see more than, say, 5 violations of a threshold, send me an alert. And that would have smoothed over all this problem, and everything would have been fine. And that's what I'm saying. When it comes to choice, some monitoring systems support rolling count on alerting, which may or may not be important to you. Some don't. There's a lot of variation between them. So that's one thing. So Micrometer also is really focused on helping you get the right information. And I can't go into all of the examples of how it does that in a short session like this. But let's pick an example for a moment here, and we'll just focus for a second on timers. So Micrometer supports counters and gauges and timers and distribution summaries, all sorts of things. But we'll just focus for a moment on timers. And I hope I'll illustrate for you here the kinds of nuances that exist in timers, especially as you're shipping in multiple monitoring systems. So timers, if you're interacting with a timer with Micrometer, you have a meter registry, which has different implementations. And to create a timer, you just say registry.timer, and you give it a name, and then you can use that timer to record a value. Out of the box, of course, Spring Boot auto-wires timers over HTTP request metrics and scheduled methods and such. But, of course, you could manually time a block of code as well. And right here, at the very beginning, there's a difference between monitoring systems. The value that's shipped to one monitoring system may be a millisecond time, and another monitoring system requires seconds, and another monitoring system expects nanoseconds. So, Micrometer smooths this over because it allows you to record once, and then the implementations are responsible for scaling that value to whatever the monitoring system expects, and you get the right answer wherever you are. The types of data that are shipped to the monitoring system is totally different from one to another. So when we go to Datadog, we ship pre-computed aggregates like average, client-side computed percentiles that help take advantage of the particular query functionality of Datadog. When we ship to something like Netflix Atlas, we're able to take advantage of its sophisticated math capabilities to do things like dynamic alerts based on, like in this case, there's a blue latency line or a throughput line up there. And we've taken that blue latency line and we've smoothed it. And then we've multiplied the smoothed line by a factor of 80, so it's the brown line right below it. So we're doing a lot of math here. And we can set up an alert simply based on if the real value, the blue line, ever drops below the brown line, alert me. Because, of course, smoothing doesn't respond as quickly as a sharp drop like you see here. And in this way, you can build an alert that responds to cyclic changes in performance in your app or changes over versions. That's a particular feature of that monitoring system. If you're going to something like Prometheus, Micrometer ships histogram buckets so that you can compute percentiles. Again, just a different feature. And this all comes from the same line of code, that same timer.record blah. It just looks different depending on where you go. Micrometer timers know how to compensate for this heady thing called coordinated omission. This is a simple but unfortunately frequent problem where if you have a series of requests coming in, but your system is in the middle of a GC pause or a system pause right before the request gets picked up and the timer starts, when we record the final timing value, we're going to miss that GC pause. We're going to miss that JVM pause. So Micrometer leverages another technology to do pause detection and compensation for coordinated omissions. All the stuff just happens for you without any effort on your part. Micrometer knows how important rolling max is to latency metrics. When I looked out there at a bunch of monitoring systems, I was surprised how many didn't offer a recent concept of what the max response time was. And that's a really important thing to look at. Let's dive a little bit more into even that concept. So remember this percentile representation we showed just a few slides ago from Prometheus. This blue line, this is a Spring Boot application that thrashes memory. It's a sample I created on my local machine and beat the heck out of it. This blue line here represents the average latency. It's about 12 milliseconds. Quite a few organizations might stop here. Average latency. This is basically what my user is experiencing. We also plotted the 95th percentile. So the 95th percentile is something like 27 milliseconds. That's kind of scary. That's already more than twice the average. We also plotted the 99th percentile. The 99th percentile is something about like 35 milliseconds. So we're now reaching something close to 3 times the average. And often you look at Grafana dashboards and such, and it stops here. It stops at high percentile values because it's easy to think, well, 99%. That's the vast majority of what's going on. I have a decent idea of what my users are experiencing. When we plot the rolling max coming out of Micrometer, we see that there was an ugly GC pause that was happening about once a second that caused the max to be 350 milliseconds. So those other 3 lines we were showing earlier are now like shoved way down on the x-axis. And we have a value that users are experiencing that's more than 30 times worse than what the average is. And that's often what we're seeing on our dashboards. That's pretty scary. I was talking to my friend Taylor yesterday, and he gave me a real-world example of a Netflix service doing 100,000 requests per second. The 99th percentile is somewhere squunched way down on the x-axis. It kind of peaks up every once in a while. You kind of see it's way down there. It's essentially the x-axis. The max is the green line. It's roughly 15 to 20 times worse than P99, the 99th percentile. And for this service, that max case is happening roughly 1,000 times a second. That's pretty scary. I wouldn't want my users to experience something like that 1,000 times per second. Actually, it may be totally fine. You know, this max may be underneath their SLA still, and everything's OK. The point is, if you don't plot the max, you don't even know, really. If you're just plotting average and you're plotting 99th and so forth, you don't really even know. To drive this home a little bit more, just a little more math here, a 1% chance of, and this is the birthday problem, right? A 1% chance of something bad happening times 100 chances is like a scary 63% chance of something bad happening. And when you get even a moderately high throughput service, the chance of something bad happening to one of your users just goes up pretty substantially. So we report a rolling max, and that's good. We're dropping down that support on monitoring systems that didn't necessarily have that as part of their instrumentation clients. That's just something you get when you use Micrometer, and that's good. I've noticed, we want to de-emphasize other things. We've noticed that there's several systems out there that report standard deviation as a metric as well on their timers. So I went back to the sample that I just showed you with the 12 millisecond average and the 350 millisecond max. And to try to put it in terms where we could even reason about it a little bit, I assume that the max was half of what it is. So assume it's somewhere around 150 milliseconds instead of that nasty 350. And the standard deviation on this whole distribution would imply to us that that max should only happen once every 39 billion times the Earth has been around, and it was provably happening once a second. That's pretty scary. So so that's what we're trying to do for you. We've done a lot of research and we've done a lot of work on what are the right metrics to record such that you get the best understanding of what your users are experiencing, and we'll try to bring those up to the top. That's all I'm going to have for you today. I do have a session tomorrow on Micrometer application metrics, and we'll dive into other areas to show you how we can help you out. I hope you have a great conference. Thanks for joining me.